Just start.
Yeah. Okay. Now you do this same thing again. Time
The
period of
time
sound.
taken for one oscillation is called time period. It is represented by the letter T. The SI unit is second. Frequency and time are represented as follows. T is equal to 1 upon frequency.
One upon
Few.
new. New.
Nu. Nu
Then
for one oscillation.
will be.
Nu is equal to 1 upon T.
So all of you understood? Yes,
Yes.
girls. What is the relation between the frequency and the time period? Both are reciprocal. So if T is equal to 1 upon nu, then nu will be 1 upon T. What do you say? You put this over here and you put T over here. Both are same. So both are reciprocal to each other. You got it? Eighth
Yes.
standard. Only Delisha is answering. Next, rest of you. Eighth standard. Did you understand
Yes,
the
ma'am.
formula?
Yes, ma'am.
Okay, fine.
Yes.
So the time which is taken to complete one oscillation. Now, what is that one oscillation? This one. Here to here and then back. This is one oscillation. So how much time is taken? That is called time period. What it is called as? Time
Time
period.
period.
This much have you understood? Now time period is noted by capital T. Here you can see T. Right? And what is the unit of the time period? It is second. That is S. How do we denote frequency and time period? It is T is equal to 1 upon nu, where nu is the frequency and T is the time period. Similarly, if I say, okay, what will be frequency? Then you can automatically say it has to be 1 upon T. This is the relation between frequency and the time period. Understood, beta? Any problem regarding this?
No, ma'am.
Now we come to amplitude. So first we did frequency, second we did time period. Now we are going to work on amplitude. Please read.
Okay, ma'am. The maximum displacement of an oscillating body from its central position is called its
Amplitude
amplitude. AB or OA, or
or
the amplitude of sound wave is the height of the crest or tuft.
tough.
It is represented by the letter A. The
Okay.
SI unit is the same as that of density of pressure.
Okay. The unit is that of density or pressure. It's Pascal. Now, if I have shown you that the sound travels in the form of waves, isn't it? Now, this is the mean value. What is this beta? Mean value, isn't it? This is one the central line.
Yes,
This distance, this is called as amplitude. What it is called?
amplitude.
So this is called as amplitude. So have you understood this? So the distance between mean and the highest point of the wave, it is called as amplitude. And over here, if we talk about the pendulum, this much distance or this much distance is the amplitude. Am I right? This is the
Yes,
central position. Huh? This is the central position. So this much distance OB or OA becomes the amplitude of the pendulum. Is it clear?
yes.
Yes, please go ahead.
Amplitude of sound, volume control, loudness, strength of the wave measured in dB, decibels, energy of the wave.
Now if you talk of the amplitude of sound, it conveys what is the volume, what will the loudness, what will the strength of the wave, and the energy of the wave. That is conveyed by the amplitude of the sound. So, amplitude of sound tells you about all these four factors. And remember, sound is always measured in the form of decibels, dB. Is it clear? Sound is measured
Yes.
in decibels, that is dB. Okay? For example, if you're whispering, it will be 10 decibels. Can you see this? 10 decibels. The wind in leaves will be 18 decibels. Waves on seashore will be 40 decibels. Are you understanding?
Yes.
Shouted conversation. You are shouting at each other. That will be 70. Vacuum cleaner will be creating almost 80. Rock music, blaring music, loud music, that will be 100. Jet engine, the aeroplane, that will be around 110. And threshold of pain, if you're getting a pain, by the sound you get the pain, isn't it? Your head starts paining. That is 120. When your head starts spinning due to the sound, it is 120. This is the threshold of the sound which has been created. What's of sounds? What are the decibels? Has been conveyed to you. Okay? I hope you have understood. Yes, better.
Yes,
Yes,
ma'am.
ma'am.
How sound travels? Please.
Sound passes through the medium as longitudinal waves.
Waves. Longitudinal waves. Say it again.
Longitudinal waves.
Okay, good.
When the vibrations are fast, you hear a high pitch. When they are slow, you hear a low pitch.
Okay. So generally, sound passes through the medium. Now, what is the medium? We are talking about air, isn't it? Which medium are we talking about, beta? Air. I speak, I talk, you can hear me. How do you hear me? Due to the presence of the medium. Which medium I'm talking about right now? Is it water? Is it solid? No, it is air. It is gas. You got it? Girls,
Yes, ma'am.
how do they move? They move in longitudinal waves. This is called as longitudinal waves. Okay? Now, if the vibrations are very fast, that means it's happening very soon. So you get a high pitch. What you get with a high pitch? If they're slow, you get a low pitch sound. Now, you must have observed in some opera concert or in TV advertisements that one lady is holding a goblet, a glass, and someone sings with a high pitched note, and the glass cracks. It breaks into pieces. Have you ever observed this sort of advertisement, Peter? That is high pitched sound. It's so sure. Even the jets, the aeroplanes, if they pass by very nearby to the houses, the window panes it cracks because of the high pitched note. Do you understand?
Yes.
Okay. So now here you can see the difference. This is the graph depicted between time and pressure. So this is high pitch. You can see the waves are very close by. Whereas this is widely separated, this is low pitch. You understand? This is low pitch. Any problem? So I've tried to make you understand with different types of graphs, with the definitions. I hope the things are quite clear.
Yes.
Now we will see low sound and high sound. Please. Again, this is a revision.
Low sound and high sound. The pitch of sound, shrillness or flatness depends on the frequency of vibration. If the frequency is high, the sound has high pitch. If the frequency is low, the sound has low pitch.
You understood now?
Yes.
Okay. So what? How it is related? Low pitch means low frequency. Simple. Directly
Mm,
related to it. If I'm talking about low pitch, it's flat sound. High pitch, shrill sound. So obviously, at high pitch, the frequency is more. At low pitch, the frequency is less. You can see this is low volume. See the height which is gained is very less, whereas the height which is gained is very high. Can you see this?
yes.
Okay, so it is less frequency. So frequency is less frequency, and here it is more frequency. You understood? Yes, beta.
Yes, ma'am.
These are not there in a book. I'm telling you. Whatever figures I'm giving you, whatever drawings I'm showing to you, it is not in a book. I'm just trying to make things simpler for you because if you see, you will understand it in a better manner. So there's a reason that I have taken these figures. Okay?
Yes.
Now, what is the relation?
High pitch is equal to a high frequency. Low pitch is equal to low frequency.
Any problem?
No, ma'am.
It's easy now
Yes.
to understand. Okay? Again, the same thing, high pitch and low pitch, but in a different manner. Let's check it out. Read better.
The loudness of sound depends upon the amplitude of vibration. If the amplitude is less, the sound is feeble. If the amplitude is more, the sound is loud. The unit of loudness is called de-
Decibel.
decibel dB.
dB. Okay,
The
that's it.
pitch
That's it.
of
That's it. That's it. Better. Okay. Now let's talk about the loudness of sound. First thing we will take it up. Now what it depends on? The amplitude. Now what is amplitude? I told you already. This is the amplitude. This is the amplitude. This is the amplitude. You understood? So the
yes,
loudness of sound depends on the amplitude. This much is okay. What is the relation? If the amplitude is less, the sound is less. If the amplitude is more, sound is loud. What is the unit to measure? Decibel. Any problem so far?
no ma'am.
Now we come to the second point, that is the pitch of sound. Okay? Please read.
Frequency of vibration in
No, no,
the
pitch of sound, better. You have to start with the pitch of sound.
yeah.
Second
The
point.
pitch of sound, shrillness or flatness depends upon the frequency of vibration. In the frequency is less, if the frequency is less, the sound has low pitch. Example: sound of a drum, sound of an adult, etc. If the frequency is more, the sound has a high pitch. Example: sound of whistle, sound of a baby, etc.
Understood? What we learned earlier, we learned
Yes,
the loudness of sound. What we had learned earlier in the first point, the loudness of sound. which depends on the amplitude. Now we are going to work on the pitch of sound, which depends on the frequency. Now you understood?
Yes, ma'am.
Okay. So this is the pitch of sound, which depends on the frequency of vibration. Frequency less, sound low pitch. Okay. For example, drum adult. Frequency is more, sound high pitch. For example, whistle. Now you can understand. So high pitch means shrill it is. जिसको हम कहते हैं तीखी आवाज जो कान को चुभती है which hurts our ears. That is shrillness. And flatness, which is okay, soothing it is. You understood?
Yes,
Hello? Understood?
yes,
Here you can see this is drum, which has got low frequency, and whistle, which has got high frequency. Now we'll see how sound travels to our ear. Please see. Sound travels to your ear how? For example, this is the alarm clock. Okay, there's the alarm clock. In the morning, it rings. The sound reaches your ear. How does it reach? Please read. Hello.
Yes, ma'am, I'm reading. The air vibrates but does not travel from the alarm to the ear.
That means air is vibrating. The air particles are vibrating. But the particles are not reaching your ear. But the particles is giving the message to the other particle. The other particle gives the message to the other particle. You getting my point? So the particle which is over here, it is not moving, but it is giving message to other particles which are on the way. Are you understanding? The particles are not moving, but it is conveying the message to the other particle. Do you understand?
Yes.
Nicely? What is actually happening?
yes,
Okay. So the particles are not traveling, it is not moving, but it is moving. What is moving? The message is moving from one particle to other particle, and then it reaches our ears. You understand? The energy travels from one particle to the other particle till it reaches our ears, and then we get up. Have you understood? Hello? Did you understand better?
Yes, ma'am.
We'll now learn something about our ears. Please begin.
How we hear sound through our ears. Sound enters the ear through the ear canal. It
Canal.
makes the
It's not
canal.
kennel. See what you said just a moment better. You said kennel, right? So the spelling of kennel is this. What is it? Kennel.
Yes.
Just now you spoke it that manner. So the pronunciation matters better, isn't it? Now when you said kennel, now what is this kennel better? This is a place where you keep dogs.
Yes,
This is a
yes.
place where you keep dogs. You know that, right? You have heard it, isn't it? So kennel is
Yes.
a place where you keep dogs, isn't it? So the meaning
Yes.
changes. So you have to be a bit quite clear, careful.
Yeah.
Yes, better start.
Sound enters the ear through the ear canal. It makes the eardrum to vibrate. The eardrum sends the vibrations to the inner ear. From there, the signals go to
Signals.
the brain, and then we hear the sound.
So you can see over here This is the pinna, the outer ear. Sound is till here, it is the outer ear, the pinna. Now sound gets in the ear canal. Can you see the ear canal, beta? So this portion is
Yes.
ear canal. One by one, I will be showing you. This is the pinna, that is the outer ear. Yes, you agree?
Yes.
So it is called as pinna. What it is called as? Pinna.
Enough.
Then the sound enters into the ear canal. Where does it ear? Where does it enter, beta? Ear canal. So this portion is ear canal, the tube. Okay, understood? Now from ear canal, there is a flap which is known as eardrum. So it knocks on the eardrum. It taps on the eardrum, and eardrum starts vibrating. Got it?
Yes.
You understand? The eardrum starts vibrating. Okay. Now this eardrum sends the vibrations to the middle ear. This is the middle ear. You see this?
Yes.
Yes. And again, it will reach all this portion of the middle ear, and then it will go here to the inner ear. So there are two ears, outer, middle, and inner ear. So what is reaching middle ear? The vibrations. From there, it goes to inner ear. From inner ear, it goes to the brain. By this eustachian tube, it goes to the brain. Got it? Yes? And then the brain registers. When it goes to the brain, it registers that what we have heard. All of you understood? And then we
Yes,
can
ma'am.
say that we heard it from the right hand side, we heard someone screaming, we heard duster banging, we heard a shout from outside, we heard a dog barking. Are you understanding?
Yes.
All these things the brain registers. Okay? I wish that you will draw this diagram, the diagram of the ear. It's very important. Okay, so whatever diagrams I'm showing to you, without fail, you have to start sketching. Without fail, you have to start practicing. Am I clear?
Okay, ma'am.
Okay, fine, thank you. Any problem regarding understanding of this function of our ear?
No, ma'am.
Okay, I will be asking you a question one by one. Let me know. What does this do? The outer ear, it collects the sound,
Ears.
right? Yeah,
Yes.
it collects the sound. And from outer ear, what is the function of the ear canal? What
Correct.
happened?
Yes.
What is the function of the ear canal? The sound travels in the ear canal, and then it hits
Yes.
the and then it hits the eardrum. The eardrum starts vibrating. The vibration reaches the middle ear. From there, it goes to the inner ear, and from the inner ear, it goes to the brain. And then the brain tells you the sound that you have heard, what it is. Do you understand? Yes? Girls, can you hear me?
Yes, ma'am.
Same thing, but in more of a detail. Let's do it. Start reading.
Structure of the human ear. The outer ear, called pinna, collects the sound waves. The sound waves passes through the canal to a thin membrane called eardrum. The eardrum vibrates. The vibrations are amplified by the three bones of the middle ear called hammer, anvil, and
Stirrup.
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 The middle ear then transmits the sound waves to the inner ear. In the inner ear, the sound waves are converted into electrical signals by the
Cochlea.
cochlea and sent to the brain through the auditory nerves. The brain then interprets the signals as sound.
So understood? More of detailing in this slide. Look over here. This is pinna, I told you, outer ear, right? So this
Yes,
is outer ear. Second, then we have the ear canal where the sound travels, right? Then we have the eardrum which is vibrating. Then this vibration goes to the inner ear. What are the inner ear? This hammer, anvil, and stirrup. You see this? These are the inner ears. Okay? These are the three small bones hammer, anvil, and stirrup. It goes over there. Here, what is happening? The sound is amplified. That means it is increased three times more. The sound is amplified. It is magnified by three times, and then it reaches the inner ear. The inner ear has cochlea, which is converting it to electrical signals. And these electrical signals are then by the auditory nerves goes to the brain and then brain registers as a sound. Any problem? Any problem?
no, ma'am.
More of a detailing we have done in this slide, okay? You will just mug it up. The names of the middle ear, then inner ear. You understand? More of this. Human ear, you can see this. So the outer ear, one by one, this is colorful, so you will enjoy. So this is the outer ear. Can you see this? This is the
Yes.
outer ear. This is called as pinna. One by one we
Yes.
will do it. Then we
Yes.
have the ear canal. What we have beta? See this one. So wherever I am marking it, please understand. This is ear canal. Next we will come to what will come to beta?
Eardrum.
Eardrum. It will start vibrating, right? Next
Yes.
is next is
Middle ear.
middle ear, where you have got the small bones, hammer, anvil, and stirrup. What are they doing? They are magnifying the sound, right? By three times. The vibration we get and vibration is magnified by three times by hammer, anvil, and stirrup bones, which is present in the middle ear, right? From here, it goes to cochlea. From here, it goes to cochlea, which is known as inner ear. See, this is cochlea. What is the function of cochlea? It is converting into electrical signals. Yes. Now, these signals are carried to where, beta? These electrical signals are carried where?
That
Where does it go, these electrical signals? Whenever we talk about electrical signals, it goes to brain. Simple.
yes.
By what? By auditory nerves. And then we hear. It is registered by the brain and then we hear the sound. Any problem? Tell me.
No,
Any
ma'am.
problem? It's not use actually, it should be versus. VS. Mobile phones versus radio. Okay, please read.
Mobile phones use radio. In one phone, the sound is changed into an electrical signal, then into a radio signal. In the second phone, the radio signal is changed into an electrical signal, then into sound.
You understood? You understood this much? What is happening? That in one phone, the sound is changed into an electrical signal and then radio signal. And then this radio signal is changed to electrical signal and then sound. This is how the mobile phones are working. So, what is the changes that you can find? Sound to electric signal to radio signal. The radio signal is changed. You can see this radio signal is changed to electrical signal and then it changes to sound. You understood? This is how the mobile phones are working. Got it? Hello. Just for your notifications, I have used. It's not there in a book, I'm telling you. You should know how the mobiles are working, so I just included it. That sound changes to electrical signal, it changes to radio signal, which is again changed to electrical signal, and then we get sound. Okay? And we will see how the telephones will work later. The time is already up, I think so. Girls, hello. Yes? Okay. So I hope you have learned quite a lot regarding sound. I hope you don't have any doubts whatsoever. And if at all, you can call me up or you can text me. Okay? Have a good day, beta, and bye. Bye, beta.
Hello.
Hello.
Yes, बोल. Good morning, sir.
Good morning, sir.
Good morning. Good morning.
Sir, your
Good
voice is
morning.
not clear. Excuse me, sir, your voice is not clear.
Okay. Now,
No, sir, it's not
Yes,
clear.
sir.
hello.
Good morning, sir. Means you are audible, but your voice is not clear.
Yeah, it's not coming clear.
Okay. 1 minute. Wait.